Hello, my name is Enrico Sciubba and I'm here to introduce the slides pertaining to Professor Özer Arnas' lecture, which was to be presented online, but for some technical reasons he was unable to put online. I had some problems in shooting this video myself. Must be a problem of age and technological capabilities. However, looks like this is working this time. Now, first of all, this is a very important presentation. Let me first discuss a little bit about the very long and well-known curriculum of Professor Arnas. He got his bachelor degree in engineering in Istanbul, then a master's at Duke, and a PhD at North Carolina State University in the US. Then he moved to only mechanical engineering. Then he moved to Germany, industrial positions. He held industrial positions for a while, several years, before moving back to the States, where he went through all of his career at Louisiana State University. After retiring as an emeritus from Louisiana State, he kept teaching at various positions throughout the US, giving lectures as an invited lecturer or visiting professor practically everywhere in the world. He went all over Europe, to Turkey of course, South America, the US, Canada, I believe in Russia, I'm not sure, China, and he's still very active. All in all, to my knowledge, he has written something like 180, 190 scientific papers. He is a fellow member of ASME, American Society of Mechanical Engineers. He has been or is still a technical editor or associate editor for several well-established scientific archival journals in the field of energy conversion systems. Now, in the latest years, he has started lecturing on a topic which is very dear to him and is very important to us, namely errors in thermodynamics. We are not talking about students' errors in thermodynamics at the exam. We are talking about misconceived teaching of thermodynamics. Unfortunately, very often in lectures or conferences, sometimes in books and in classrooms teaching, we see mistakes or misconceptions passed from the instructor to the student. And this is very unfortunate. And this is a crusade that Özer, we go on first name basis with Professor Arnas because we have been knowing each other since 1984, I think. He has taken this task of finding, exploring, explaining, and instructing how to avoid these mistakes. Therefore, this slide presentation is very important. I suggest everybody to read it very carefully, to ponder it very carefully, and to keep the file in your computer, because now and then you are bound to go back to it and look again at it to get some inspiration to correct your errors if you have made any. Now, the first 17 slides are general principles. They are very concise, a very clean and synthetic presentation of the principles of classical thermodynamics. The second batch of slides, 18 to 29, deal with entropy. Entropy is a very controversial quantity, not because itself is controversial, but because many lecturers and many researchers still don't have a clear concept of what entropy is and how to use it. Professor Arnas makes it very clear, very crisp, and you should really go through the presentation and see for yourself how entropy can be derived from prime principles, what it means, how it can be used, what does entropy generation, irreversible entropy generation mean, and so on. The next 2 slides or 3 slides are about exergy, which is a topic very well correlated with entropy. Professor Arnas uses the symbol capital A for an exergy. Usually in Europe the capital B is used, and more frequently capital EX, X symbol. But however, his formula is exactly the same that we use in our books and lectures, and the definition is crisp and correct. In the next slides, next batch of slides, 33 to 58, Professor Arnas goes into some examples for students, very detailed, and the discussion about material properties. Material properties like specific heats, expansion coefficient, and this stuff are quantities that are external to the theory of thermodynamics. They are not fundamental properties. They are fundamental properties of the materials, but they are not state properties. But they can be related to state properties via a series of transformations, which Professor Arnas goes through very carefully and very detailedly. Maxwell relations, the Gibbs relation, of course, the Legendre transformations, and the Jacobians. This is very important because you want to avoid the classical student mistake of saying that the delta enthalpy in a transformation is Cp delta T. This is not Cp delta T, because Cp changes with temperature according to a formula which is given by Arnas, which is a function of pressure and temperature. In the case of Cp, only of pressure. Only of temperature, I'm sorry. So these material relations are very important, because when you either design an experiment or put up a theory, or formulate a theory, or put up a correlation, you have to relate these material properties with the equilibrium properties of the transformation. This is essential to get decent results and congruent results. The next 6 slides, 59 to 65, deal with the design of experiment. This is also a very important topic. Professor Arnas' main concern is that people do not examine carefully the assumptions and the implications of the assumptions made in the setting up of the experiment, the effects of these assumptions on the results. Read carefully, because if you don't do this step very carefully, very analytically, and to a very deep stage, your results will be either wrong, or your interpretation of the results will be wrong. In the last few slides, 13 slides I think, 66 to 79, Professor Arnas goes into heat transfer. He's also a specialist of heat transfer. The concern here is that, again, let's look at heat transfer correlations. They are used everywhere in the design of heat exchangers, condensers, everywhere. Now, these correlations are known to be somewhat approximate, okay? We joke when we talk about these things, about how precise a correlation is, we say, well, 20% is a good target. However, these correlations are based on some fitting of empirical data. They are semi-empirical, and it's very important that you analyze the conditions that were assumed in the derivation of these correlations, the assumptions. Professor Arnas makes a very good example about the assumption of a laminar flow in the boundary layer of the gas phase in two-phase heat transfer. This is a very important topic, because if the flow is not laminar, then the heat transfer characteristics are different. Not many people underscore, not many researchers underscore this, the importance of this congruency between the assumptions, the transformations, and what you are looking after, what you want to get from your design or experiment. Okay, so this is all. I hope this is short enough as a presentation, but really I want to underscore the necessity for you to read it, to understand it, and to keep it in your computer. For myself, I have 2 or 3 of Professor Arnas' lectures on my computer, and I read them now and then. By doing this, you will improve your knowledge or understanding of thermodynamics, and you will do service not only to yourself but to the general field, because if you produce better results, the general field will go ahead, and that's what we need to proceed, to make progress. Okay? Thanks to Professor Arnas for this effort, and good reading for you, and I hope this is a good contribution of our conference to the let's say dissemination of good principles of thermodynamics. Thank you very much.